In this video, we're going to continue our examination of determining if trinomials can be written in quadratic form and factor and solve. Just now, we're going to expand the concept into trinomials with rational exponents, with fraction exponents. To determine if a trinomial with fraction exponents can be written in quadratic form, we still look for the same pattern that we saw previously. We had x squared, and we had x to the first, plus our constant. We had x to the fourth, plus x squared, plus our constant, x to the sixth, plus x cubed, our constant. And so we saw that our middle exponent has to be half of the leading exponent, the degree. And so what's interesting for this is this pattern doesn't just go down, doesn't just increase, we can also go backwards. I can have, if you look, 8, 6, 4, 2, I can have a first power. And then that would be 1/2. And I can go back and back. I now see a fraction exponent, a rational exponent. So this pattern can hold to be true as long as the degree of the middle exponent is half of the degree of the first one. If our middle exponent is half of the leading exponent. It doesn't matter if they're fractions, it still holds to be true. So we take a look. We have x to the 1/2 minus 8x to the 1/4 plus 15. So first look at your exponents. Is 1/4 half of 1/2? And the answer is yes. So I know I can write this in quadratic form. And again, the question now is how? How, once we figure out if it can be written in quadratic form, do we go about doing it? And we use the same idea. It doesn't matter that they're fractions. It's still going to follow the same pattern, the same technique. Treat it as if it were a regular quadratic. Treat it as if it were x squared minus 8x plus 15. And remember I said before, I can use a different variable for this so we don't get confused. So let's change that x squared to a y squared. So I have y squared minus 8y plus 15. I would factor into y minus 5 and y minus 3. They multiply to give you 15, add to give you negative 8. So if it were written like this, I could do it. But the pattern still holds to be true, even though they're fraction exponents. What you need to look at is when you split it, the exponents of the first term in each factor. We split the first exponent in half. So half of 1/2 is 1/4. So we get x to the 1/4, x to the 1/4. And then we follow the same technique. They multiply to give you 15 and add to give you negative 8. That's minus 5 and minus 3. To solve this is a little bit trickier. What you do is the same idea, set each factor equal to 0 and solve. So you get x to the 1/4 equals 5. Now remember, when solving for x, you want a degree of 1, you want an exponent of 1. So you do the opposite of your exponent. So the opposite of 1/4 is raising it to the 4th power. That will cancel out both of these and just give you an x. So if you raise the left side of the 4th power, you're going to have to raise the right side of the 4th power. And that gives you 625. Same idea here. Set x to the 1/4 minus 3 equal to 0. So x to the 1/4 equals 3. To cancel out a 1/4 power, you raise it to the 4th power. And that gives you 3 to the 4th power is 81. And so those are my answers. X equals 625 and x equals 81. So even though there's rational exponents, even though there's fraction exponents, the pattern of writing a trinomial in quadratic form still holds to be true. determine if the middle exponent is half of the first exponent. And then, again, to help you out, maybe write it as a quadratic. To split it into the factored form, you split the first exponent, the degree, in half in each factor, and then just use the values you found over here. Set each one equal to 0 and solve. So we're going to look at in the next video a couple of examples on factoring rational equations in quadratic form.